All coordinators are requested to switch on their cameras, please.
Sir, am I visible?
Yes. But put your mic on mute. Just switch on your cameras. Still, a lot of cameras are off. Thank you.
Am I visible, sir?
Yes.
Am I visible, sir?
Yes.
Okay.
Put your mic on mute.
ठीक है ज्वाइन करोगे
Good morning, everyone. Chairman is joining in a moment. Kindly start the program. Maybe go ahead with the lamp lighting and Saraswati Vandana, please.
Okay, ma'am. Honorable dignitaries, our most valued speakers, and all the participants, a very pleasant good morning to one and all present here. Thank you for being with us today. It's my privilege to welcome you all on this occasion. I, Dr. Shali Sachdeva, on behalf of National Institute of Technology, Delhi, would like to express my sincere gratitude to our chief guest, Jaswinder S. Ahuja ji, our guest of honor and the chairman of AICTE, Professor Anil D. Sahasrabuddhe ji, and the advisor of ATAL Academy, Dr. Mamta Rani Agarwal ji. A warm welcome to the core team members, Deputy Director Amit Datta ji, Girdhar Lal Garg ji, and IT staff members of ATAL. I would like to welcome all the coordinators, technical staff members, and participants for taking time and being a part of this program. AICTE, in its endeavor to encourage academic excellence in technical education, has taken several quality initiatives, which also include enhanced impetus on the development of the faculty teaching in colleges across the country. The AICTE Training and Learning Academy is one such initiative that has been conducting various FTPs for imparting, upgrading faculty's knowledge in thirst and emerging areas. Given the unprecedented COVID-19 backdrop, this year 1,500 FTPs in various emerging areas have been scheduled in online mode, and 63 such FTPs are commencing on 26 July 2021, that is today. These FTPs are being conducted by various prominent organizations such as IITs, IIMs, IIITs, NITs, IISc, ISI, JNU, BARC, DRDO, universities engaging distinguished experts from academia, industry research organizations from within the country and abroad. So this was a brief intro. Now, with the due consent from our chief guest, Jaswinder S. Ahuja ji, I would like to request the IT team of ATAL for virtual lamp lighting and Saraswati Vandana. Sir, do we have your permission, sir?
Yes, please. Please go ahead.
Thank you so much, sir. Yes, please, IT team may please start. Thank you so much. Now, I would like to welcome Dr. Mamta Rani Agarwal ji, advisor of ATAL Academy and former additional secretary, Association of Indian Universities, former joint secretary, UGC, and director education, New Delhi. Mrs. Agarwal has been an international speaker at the University of Columbia, New York on urban education and in the Global Summit on Reforming School Systems in Global Cities, New York. She was the president of India's nominee on the Board of Governors of National Institute of Pharmaceutical Education and Research, Kolkata, member in other BUGs, and resource person on many academic subjects. She has edited 5 volumes reference book on National Education Policy 2020. With this, I would like to hand over to ma'am. Ma'am, please.
Thank you so much for such generous introduction. Good morning, a very, very good morning to all of you. Our distinguished chief guest of today's session, Jaswinder Ahuja ji. He is Corporate Vice President and Managing Director, Cadence Design Systems, founding member and former president of VLSI Society of India. Honorable Chairman, AICTE, Professor Sastri Buthe, a very visionary and dynamic academic leader. Eminent friends from academia, and dear participants, it is indeed my proud privilege to speak and address this august gathering on one of the most prominent and value addition schemes of AICTE, that is AICTE Training and Learning Academy. We very fondly call it ATAL. We have just now witnessed our Guru Purnima. So I am reminded of very powerful words of Swami Vivekananda. He alone teaches. He alone teaches who has something to give. For teaching is not talking. For teaching is not talking. Teaching is not even imparting doctrines. It is communicating. It is communicating with these powerful words simply translate into need for passionate, energized, motivated, and committed faculty members. And all of you would agree and acknowledge that with the progression of disruptive technological advancements and COVID pandemic, there is a paradigm shift in our teaching learning process. There is a total shift in the academic landscape. Our existing current education is cross-cultural, collaborative, cross-institutional, multi-directional, enabling convergence of men and machine, exploring new pedagogies, new academic landscapes. Our students are no longer mute spectators, but they are effective creators of knowledge. Teaching is no longer monologue. The system has become self-paced, self-directed, and interest-based learning ecosystem. Our techniques of teaching and learning have changed, where Skypes, wikis, blogs, video conferencing, animated laboratories, virtual classrooms, and personalized data from interconnected world have become some of the teaching tools. So often a question, very often a question, relevance of teachers in such changing paradigm shift of teaching learning. But in my very, very personal opinion, no technology can ever replace a teacher. But technology in the hands of a good teacher is truly, truly transformational. It is empowering. So with these towering changes, with these gigantic changes, what we need is continuous, comprehensive, relevant, project-based, hands-on training of our faculty members, and more so in emerging and thrust areas. And it is AICTE is among so many innovations which AICTE has been doing. It has been implementing NEP even before it came into existence. We are translating our technical content in various languages, various regional languages, and 11 we have already completed. We are truly, truly encouraging multidisciplinarity. We have allowed students to go for arts, liberal arts, and all other subjects along with highly technical subjects. So it is we at our commitment at AICTE that we are hand-holding and trying to take our teachers to the next level in these emerging areas. The anchor has covered already all the laurels which ATAL Academy has done. It has done a wonderful value addition in faculty development, and it has achieved unprecedented participation, unparalleled growth. Last year, more than 1.65 lakh faculty members were trained in online mode, and ATAL Academy has been awarded from World Book of Records, London. And this success is primarily attributed to all our partnering institutions, experts, coordinators, and amazing AICTE team. And most importantly, my dear participants, it is your heartfelt participation because of which ATAL has reached where it has reached. So we have made a huge success, and I applaud each one of you, all of you. Now, what is our primary objective at ATAL? That our faculty development programs must ensure that our colleagues are motivated, engaged, fascinated to acquire new knowledge, associated skills, and visualize their applications in solving real life problems. It is in this context, solving of real life problems, that symbiotic and strong academia industry linkage becomes imperative. An academic institution's ability to help industry with innovations, inventions, and consultancy. And same way, the requirement of the industry to fall on various human capital developed by the academia is the core mission of contemporary global academy. So I feel the 5 P's: purpose, people, product, process, and profit. Financial profit in terms of industry, and intangible profits, that is development of human capital, are the 5 P's where we really, really need a meaningful academia industry relationship that would evolve around a strategy in pursuit of opportunities based on realization of interdependency to build synergy, appreciation of interest to maximize benefit, and assessment of concerns to minimize risks at both ends, academia as well as industry. It is also an indicator of the institutional quality that corporates are willing to fund research and academia is prepared for such knowledge transfer activity from academic innovations to the industry or say patenting and a product development that will be useful, enhance the quality of life of our community, of our nation. There are too many benefits of academia industry linkage, but without getting into details because I want our expert to speak about it. But anyway, closer collaborations is required between industry and higher education institutions to derive and drive passionate, good quality innovations and research. It is important that our esteemed colleagues participating, friends from academia, feel a deep sense of achievement post these faculty development programs. They have valuable take homes, impacting class transactions in emerging thrust areas, and apply this knowledge to solve real life problems. So, dear colleagues, you are agents of change. I say in all my in all my addresses, pillars of quality education deliverance, responsible to transform lives into competent, cutting edge, humanitarian technocrats who encourage inclusivity, commemorate diversity, and celebrate absolute excellence. It is time to hear from industry leader Jaswinder Ahujaji, former chairman of the India Semiconductor Associations. He serves on the governing council of Software Technology Parks of India, and is on board of Electropreneur Park, the first ESDM electronic system design and manufacturing incubators in India. Academically, he is BTech in electronics from IIT BHU, MS Computer Engineering from Northeastern University, Boston, and Executive MBA from Stanford. After we hear our Honorable Visionary Chairman Sahasrabudhe, we would just be very eager to listen from Ahujaji. All the very best. Thank you so very much, my dear participants. Thank you.
Thank you so much. Now, I would like to extend my warm welcome to our guest of honor, Professor Anil D. Sahasrabudhe, currently Chairman of AICTE. In his 33 years of profession, from starting his career as scientific officer at
Dr. Shelley, please stop it. No, that's good enough. The time is short, so I would like to continue with a little about what we have been doing in different formats. At the outset, I would like to thank Dr. Jaswinder Ahuja, Cadence Design Systems Limited, who has kindly agreed to be the chief guest for today's program. A man who has excellent not only education but contributed immensely towards industry in terms of whether it is software development, STPIs, or in terms of other industry design systems. So I think we are very lucky to have him on such an important occasion. Dr. Mamta Agarwal has pointed out very beautifully about the role of teachers in such academy programs and how they can get empowered and then in turn take it to the students. Girdhari Lal Garg and my other colleagues from AICTE who have joined this platform today, as well as 62 odd institutions from where today's workshops are being launched. These are all 5-day workshops on all emerging areas, ranging from AI, IoT, machine learning, deep learning, robotics, 3D printing, blockchain, cyber security. Do you call it, and anything which is going to happen in the future, next 10 to 20 years is part of all these programs. And this is what is invigorating. Because when we change the curriculum, we find that our teachers themselves who graduated 10, 20 years back never had an access to this kind of an education. And therefore, if they have to handle classes in these domains, they are found wanting. And then students sometimes will make fun of them because students are through internet, through various types of sources, would probably be one notch above the teachers. And that makes it much more difficult for our faculty members. And that's why putting them on the same level as that of what students probably are is going to be very vital and important. And in fact, they must be one step ahead. And that is why these faculty development programs are very intensive, 1 week long. These are almost like 3-credit courses. There are 14 modules. You can imagine 14 lectures from different eminent personalities coming and giving you those things. And then there are assignments. You are made to work hard You are also required to give quizzes. So almost like student, you will be competing amongst your own colleagues from different colleges in India, different universities in India, and some of the industry experts giving you hands-on training, some of them giving you theory background. I think you will be holistic in those domains. And then if you are going to class with confidence, and there are empty number of courses also on whether it is MIT edX, whether it is Coursera, our own Swayam. I think you will be able to learn on your own further beyond what is taught in these 5 days. And with that, if you are going, I think you will certainly be doing a good job. Students will appreciate the kind of effort that you are putting in to bring them on par with the rest of the world. And that is why these academies, which we started 3 years ago, essentially earlier in the face-to-face mode with about 50 participants. Today, we have graduated to using online mechanism. And in the pandemic, there was no choice. So using this technology domain of using platforms, 200 people can join together. And we are able to train more than 100,000 people last year in about 948 workshops. This time, our bureau, Mamata Agarwal now and earlier Sony, had planned for 1,300 programs to train 2 lakh faculty members. I think this is amazing. Nowhere in the world such an initiative has been taken. And therefore, we are very proud that whatever AICTE is doing to contribute, not only in terms of faculty development program, but in terms of new national education policy. We have already gone digital. There has been a paradigm shift in education, the way we handle our classes. Even after the pandemic, I'm sure some of the lessons learned are going to be used in terms of what we call today as blended learning, hybrid learning, or MOOCs. We will use every possible mechanism in order to make our students industry ready. And that's very, very vital and important because industry quite often talks about students are not employable. And some of the challenges that we had earlier was every institution does not have expertise in everything. And therefore, students were bogged down by learning whoever is available. And today, our gurus can be anywhere, from any part of the world. You can be from as far as east in Australia, New Zealand to Singapore and Japan to also towards west, whether it is US or Canada. You have the whole world at your disposal. Faculty or the experts drawn from industry and academia from anywhere can be rolled in these 14 modules, and you will be trained in an excellent possible manner. So make use of synchronous, asynchronous mode, learn, and this learning will never stop. Right from birth to death, we are supposed to be learners. And something new comes up, we cannot say that I don't know this. You have to learn that. Maybe it will take a couple of days time, sometimes 1 month, doesn't matter. If there is a new technology which has emerged, we have not been taught in our curriculum in our university, should not say that, sir, we don't know this. I must be prepared for lifelong learning and learning by oneself. And today it has become so much easier compared to earlier during my time and that of Jaswinder Ahujaji's time. We had only one choice, that go to the library, search, hunt for the book. If it is not available, try to go to another institution's library. He must have done it in BHU. He must have done it in wherever he went. But today, late 90s onwards, the whole world is at your doorsteps. You can just at the click of the button, you have the entire information. But our students sometimes get carried away by reading something on the various pages of the internet. That is what it is. Sometimes it is not accurately presented. And therefore, conversion of that information, which is at their access, into wisdom. Knowledge and wisdom is important. And that is the role of the guru, the teachers. And therefore, we must have all of this together with technology. Teacher's role is becoming like a mentor, facilitator for learning. Learning should be according to what we cite in our Vedas and Puranas and our ancient times, that we had Gurukula system. This is a new Gurukul. So in the new Gurukul, on one side there is a technology, there is an internet, but on the other side, a human being, human face is also equally important. And if we are able to do it, continuous development of both faculty and students will emerge. We have made internship mandatory. Some of our industry friends, like I would like to request Jaswinder Ahujaji, not only him from his company, but all their colleagues in industry bodies, be it FICCI, NASCOM, or the CII, we want internships. Our students should be aware of what all happens in industry when they are still getting educated. In their 4-year program, we have made 6 months internship as mandatory. But there are very few industries who are coming forward. We have 10 lakh students, 1 million students entering the system annually in engineering itself. Another 1 million join in other domains of architecture, pharmacy, management. So these 2 million children who come into the system, they need internship. And unless industry also comes forward and shake hands with us, it's not going to be possible. So my appeal through Ahujaji is to the rest of the industry as well, that you must come forward and provide internship, either 3 summer vacations or 1 full semester, as the case may be, depending on which university and college has what curricula. This is one very important thing. Just now, I got delayed by a couple of minutes because I was in Pune, College of Engineering, Pune, where the first Fab Lab in an educational institution was set up way back in 2009. And this was in association with MIT USA, one of very prominent professors of physics, actually not even engineering. He is a physics professor, Professor Gershenfeld, Neil Gershenfeld, who said 5th lab conference, Fab Lab conference to be held in Pune. And we had the encouragement coming actually for MIT from India. Please remember, there is a small place called Pabal, Vigyan Ashram. And the Vigyan Ashram, Professor S.S. Kalbag developed this particular lab for school dropouts. How do we train them? How do we make them employable? And that was an inspiration for MIT to create Fab Labs. And the 5th Fab Lab conference was held exactly, 12 years ago in 2009 in Pune. And that time another pandemic was on, not so much in large scale. That was called SARS, that came from Singapore, you must be remembering. And the delegates then also were wearing masks and using sanitizers was the first time that ever we saw. And during pandemic, we have all got used to it. How do we take care of our health? But all the domains have got transformed in the last 12 years. And we have so much of enrichment of knowledge. How do we dedicate it to our faculty members and in turn to our students? Problem solving skills through our hackathons. Multiple entry, multiple exit, which our new education policy talks about. Academic bank of credits. How do we support research? All of this needs training and up-to-date information, up-to-date knowledge for our faculty members. And AICTE's Training and Learning Academy is doing a small step in that direction. Of course, it has got world record, but our faculty members are 4-5 lakh. If you have trained 1 lakh is not enough. All 5 lakh faculty need to be trained. And that is the goal. Maybe in the next 2-3 years, we will achieve that goal. And my industry friends also will help. My academic institutions like IITs, NITs are also pitching in to help our AICTE to conduct these programs. And let us make it happen. A new India is to be created, not just digital India, but also humanistic India, India which will show the world that we were once Vishwaguru and we will again become Vishwaguru. Thank you. Namaskar.
Thank you so much, sir, for enlightening us. Now, I would like to extend a warm welcome to the Chief Guest of Common Inaugural, Jaswinder S. Ahujaji. Namaskar, sir. He did his BTech in Electronics Engineering from IIT Varanasi, MS in Computer Engineering from Northeastern University, Boston, and Executive MBA from Stanford University, USA. Jaswinder ji is the Corporate Vice President and Managing Director of Cadence Design Systems in India. He leads Cadence Global Customer Support and Educational Services Business and was the Chairman of India Semiconductor Association in 2008-2009. He has also served as a member of Executive Council several times. Currently, he serves on the Governing Council of Software Technology Parks of India and is on the board of Electropreneur Park, the first ESDM electronic system design and manufacturing incubator in India. Being an industry leader, Jaswinder S. Ahujaji is requested to share his views. Over to you, sir.
Just one sentence, Jaswinder ji. We got delayed a little bit, so you may take your time. That time which was allotted to you, it is still with you. Thank you.
No worries. Thank you. Thank you, Dr. Sachdeva. Thank you, Mamta. Thank you, Professor Sahasrabudhe. It's my pleasure to be here this morning. I was broadly aware of what AICTE does, but listening to Dr. Mamta Agrawal and Professor Sahasrabudhe this morning, I am quite amazed at a lot of the initiatives. I mean, I was aware of some of them, but not quite the full scope of what AICTE has been doing to move technical education forward in India. So this is actually quite laudable. With your permission, I am going to share some slides to help me with my talk this morning. Please let me know when you can see the slides.
Not yet, sir.
Not yet.
Yes,
Yes.
It has started. It has started. Yes.
Okay, thank you very much.
All of you are
I'll go.
to keep your mics in a mute situation. Please do not put on your mic.
So I wanted to talk about semiconductors and electronics industry because that's the industry that I belong to. That's the industry where I have my entire spent my entire career. And I've organized the talk in quite simple 4 sections. I'll talk about a little bit of the story so far. We can't see where we are going unless we know where we are coming from. I'll speak to some of the global trends in electronics, and I can already say that it's very encouraging to see that a lot of the FDPs that are happening this week are very well aligned with the trends that I will speak about. I'll introduce the concept of intelligent system design, which is a bit of a new paradigm that we see emerging in how electronic systems are being designed, and share some of my perspectives, if you will, on the implications for education. And again, I have to confess that I've learned a lot already through the introductory remarks that have been made this morning, and I'm very encouraged by what I have heard this morning, and some of the thoughts that I will share you'll find that they are very well aligned with what has been shared earlier today. So in terms of the evolution of the semiconductor industry and the electronics industry, at the core of it, I think we are all very familiar with this, is the Moore's law, which basically says that the number of transistors that can be incorporated in a chip will exponentially double every 24 months. Gordon Moore of Intel introduced this in 1979, and for the most part, this has been true up until now. What's actually more interesting than the Moore's law to me is the inverse of Moore's law, because that is really what's driven the growth of the semiconductor industry, which says that the cost of implementing any functionality in silicon halves every 2 years, which means something that cost $1 million 25 years ago is going to cost $200 or less today. And there are actually enough examples to bear this out. For example, a PlayStation or an Xbox available today for about $250 has the same power and performance and capability that a multi-million-dollar military flight simulator had back in the 80s. So we've seen enough examples of this. Again, Professor Sahasrabudhe has seen the evolution of the industry. Some of the others in the audience might have also witnessed it, right? We've seen it go from mainframes to mini computers to desktops to laptops to today the average mobile phone that each one of us carries has more uh, performance and capacity and capability than a large mainframe did 25 30 years ago, that used to occupy a whole room and required a team of 10 15 20 people to operate that thing. But what we are also observing is that the Moore's law, which is all about CMOS scaling, is starting to approach some limits. Today 7 nanometer process node is in mainstream production. We know that the foundries have 5 nanometer process node ready for production, and designs are being done, and we should see that go into production sometime in the next 1 or 2 years. We are currently collaborating with the foundries, helping them get ready for the 3 nanometer process node and the 2 nanometer process node. And in some instances, they are attempting the 1 nanometer process node. But we know that at some point, CMOS scaling will reach its limitations. And obviously, that's where the new materials kick in, quantum computing and some of the newer techniques that are being explored right now. Early stages of research, but they could become commercially viable sometime in the next 10 to 15 year period of time. The ITRS, which is the International Technology Roadmap for Semiconductors, started to say that, look, CMOS scaling will end. New materials may take some time to become commercially viable. The future for the foreseeable next 10, 15 years is all about heterogeneous integration. And so the concept of more than more has been emerging over the last several years. On the one hand, we see that CMOS scaling will continue surely up until 3 nanometer, may go all the way up to 1 nanometer. But increasingly, we want to do real systems on a chip, and real systems on a chip is going to require heterogeneous system integration. Things like we've heard about things like chiplets emerging. We've talked about system in a package, where we can take CMOS, largely digital, some analog in an earlier process node together with imaging, photonics, MEMS, RF, sensors, analog, put them all together and create a real system. So this is really what's driving the industry at this point in time. A lot of the innovation that's happening is all around heterogeneous integration, enabling heterogeneous integration, and building complete systems in a package. So what are some of the global trends in electronics? I'm sure you've heard the phrase data is the new oil. And I think what's driving the industry at this point in time is all about data. We've seen a complete explosion of devices that generate the data. These are sensors that are used in IoT networks. These are the handheld devices that each one of us carries. So we are creating large amounts of data. So a lot of innovation needs to then go into transmission of this data, which is all around 5G, storage of this data, which is, new storage techniques, memory, high density memory, and things like that. And then processing this data. It's the analytics, and that's where hyperscale computing and machine learning come in, because large volumes of the data that's being generated is unstructured data. There's a very interesting statistics that are being published which say that less than 2% of the data that's being generated today is actually being processed. And that's because the amount of compute power it requires and the techniques for processing it that are needed to generate meaningful insights are not quite there yet. So a lot of room for innovation, a lot of focus from both industry and academia and research in these areas. If you look at it from application domains and the like, clearly the big focus areas right now that are driving growth in electronics and semiconductors is, number one, hyperscale computing, right? This is all about the very large data centers, and the data centers are evolving. In the past, we used to build these data centers using standard devices, standard processors, standard memory architecture, standard storage architectures. Today, we are talking about hyperscale computing data centers that are built based on purpose-built hardware, which is targeted for specific applications. So depending on what type of processing you want to do, a unique stack of hardware becomes available that's optimized for processing that workload. So the hyperscale data centers themselves are emerging and evolving, and there's a lot of innovation that's happening in unique processor architectures. And a lot of it is driven by data science and machine learning, right? Which, by the way, is a generational trend, right? I mean, there is this concept of the sciences of the 3 Ps, right? And we talk about the first one being the science of place, which is all about geometry. That's well over 2,000 years old, and it's still very relevant. The second one is the science of pace, which is all about calculus, and that's about 500 years old, and it's still very relevant. And the third one is the science of pattern. And maybe with data science and machine learning, we finally have a way of computational models for the science of patterns. And again, if you think about the science of place and pace and how relevant they've been over a period of time, maybe this is the beginning of a seminal wave that will last us for another several hundred years. So we are at a very interesting inflection point in the evolution of the industry. Now, the data that's being generated, we talked about processing a little bit, but then the data needs to be communicated, and 5G is sort of the first evolution of that standard that creates that allows us for ubiquitous communication, right? Man to machine, very low latency, very high density, very high speeds. Any data is available anywhere, anytime. that you want it. And 5G communications really enables that. I talk about autonomous vehicles, and I think that's another very interesting trend that's driving electronics and semiconductor, because this requires very, very high levels of reliability, very high levels of stability. When I talk about autonomous vehicles, I'm not just speaking about cars. I'm speaking about also drones and UAVs of other kinds, and flying taxis, and the list goes on. Talking about autonomous vehicles, clearly, I mean, if you look at an electric autonomous vehicle of the future, it's basically a computer on wheels with a lot of complex dedicated hardware for processing of data being generated by a very large number of sensors, plus internal communication networks that needs to be self-controlled, right? All of the processing needs to happen within the automobile. And that introduces the whole concept of edge computing, right? Because we don't have, for latency reasons and the fact that all decisions need to be made in real time, we don't have the luxury of sending this data over even the 5G network to a data center for it to make some decisions and send it back to us. So all of it needs to happen for the most part, other than certain broader patterns that we want to communicate back to the data center for training purposes later on. We want the decision making to happen in real time within the automobile. Now, talking about electric autonomous vehicles, right? I mean, one of the biggest areas of focus and research, at least for electric vehicles, to make them commercially viable mainstream, is further research in battery technologies. I mean, battery technology is one that's not progressed at the same rate as many of the other technologies that are going to go into these autonomous electric vehicles of the future. So battery technology is one big thrust area, and that is a lot of investment is going into it. A lot of research is happening, but a lot more needs to happen. And the last of these trends that I want to talk about is industrial IoT. This is mostly, again, around the application of things like machine learning and data science, convergence of hyperscale computing with robotics, and some of the newer techniques, like was mentioned earlier, things like 3D printing and the like. So these are some of the major electronics trends that are driving our industry. And I talked about, introduced the concept of edge computing a little bit earlier, and I think really there are three application areas in today's context that are going to drive edge computing. That's obviously the smartphones that all of us use, autonomous driving, and industrial 4.0. Moving on to the whole concept of intelligent system design, what's happening is, as I mentioned earlier, if you take the example of a classical laptop that each one of us use, that laptop is general purpose hardware. That laptop has a lot more capability and capacity and performance that any one of us uses. In reality, we are using maybe 10, 15, 20% of the capability that the laptop has to offer. And so the other way to look at it is that there is 80% wastage, could be power wastage, could be cost wastage, no matter which way you look at it. There's about 80% wastage in the manner in which that the economics of how that whole system works. If you look at the ubiquitous nature of electronics today and the complete explosion of all the places that it is becoming so very pervasive, I don't think we can afford that wastage. And if nothing else, just for the sake of power, we just can't afford to waste that much amount of power. So we need purpose-built hardware. Purpose-built hardware means you need to start with the end system in mind, the end application in mind, and say, okay, if this is what the application or the system needs to do, what is the optimized hardware that we need that gives us the right amount of performance, power utilization, and cost? And that results in many design. Sorry, that results in many design challenges.
There is some anyone's. Kindly, all of you, mute yourself. Admin, post admin.
Yes, ma'am. Ma'am, continue.
Okay. So we need to look, I mean, as I mentioned, even the hyperscale data centers today, right? The single largest bottleneck in operating a data center is the power cost. That's the single biggest operating cost. And so power consumption and associated costs and global warming is a big thing on everybody's mind. And so if nothing else, just for power consumption's sake, we need optimized hardware. We need hardware that consumes the minimum amount of power, which means it needs to focus on doing just what it is needed to do and no more than that. So we need to take a top-down view towards uh, designing our system first and then looking at optimized underlying silicon that gives us the right performance for that end application, and to acknowledge the fact that everything going forward is going to be intelligent. Everything is going to require a processing element. There is no electronics that doesn't do a significant amount of processing. And this is whether we look at it from a point of view of pervasive intelligence and intelligent systems, or we look at it from the point of view of edge. No matter which way you look at it, processing is becoming an integral part of every single electronic system. There is no electronics that doesn't have a processor inbuilt into it. So just one plug for my company. I mean, we've really looked at how we approach what we do in light of these trends and adapted our strategy going forward to what we call the intelligent system design strategy. Traditionally, we have been in the EDA, or the electronic design automation business, which is the software that's used for silicon and other electronic design. That remains the core of our business, which is design. You see the inner circle of design excellence. We also recognize that our core competency is computational software. That's what we are really good at. That's what we specialize in. And so extending our core competency in light of these overall industry trends, we have expanded, or our growth trajectory, our expansion is in the areas of system innovation and pervasive intelligence. A lot of the R&D investments that we are making internally, plus a lot of the acquisitions that we are making, are aligned with that. I won't speak in a lot of more detail around it. We also recognize some of the verticals that are big growth drivers again over the next 5 to 10 years: consumer, hyperscale computing, mobile, of course, communications, which is largely 5G, automotive, aero and defense, industrial, and health and medical. And everything that we put together needs to be cloud enabled in today's context, right? So this is a very high level summary of the direction that we as a company are taking. Okay, now let me switch into implications for education. What does all of this mean for education? And I really want to start with this one phrase that we use at Cadence, which is, we've got to help our customers unleash their imagination. Electronics and semiconductors is one area where I think we have to imagine the future and then create it. And if you look back in history, that's what we learned. The devices that we take for granted today, the devices that we depend on today, our lives would be incomplete without them. 10, 15 years ago, vast majority of those devices did not exist. In fact, we did not know that these devices could exist. We had not imagined these devices. We did not ask for these devices, but somebody imagined these devices, created these devices, and today they are such an integral part of our lives, and we depend on these devices. So that's the first theme that I want to leave you with, is that we've got to prepare our students today who will become engineers of the future to help unleash their imagination and creativity. I think that's a very important part of what education needs to accomplish. The second is a question I'd like to ask is that, I'm sure most of you are familiar with this, right? If you look at sort of a balance between breadth and depth, breadth across knowledge and sectors, and depth, which is really becoming a specialist in one area, what kind of engineers does the world of the future really need? Is it a tall engineer, which is called the I-shaped engineer, which specializes in one area? A T-shaped engineer specializes in one area, has a broad exposure to more than one area. A pie-shaped engineer specializes in two areas and broad exposure in multiple areas. Or a comb-shaped engineer, which is depth in multiple areas and broad exposure to even more areas. So I'll make the assertion here that given the nature and the way in which technology is evolving and emerging, the world needs more comb-shaped engineers and not the IT or pie, right? That is just an assertion I'll make again from my experience. What does all of this again, when you wrap it up, What does all of this mean? Now, I'm sharing some of my observations from interacting with young engineers that are joining our company from multiple institutes. I'm sure many of those, or if not all of those institutes, are represented in today's participants, among today's participants. And what I'm observing of what's needed to succeed in the industry. 5 critical skills. This list could just as well be 10 or 20 or whatever, but I've chosen to focus on 5 that I think are perhaps more important than the others. First one is opportunity selection. Now, when I started putting this slide together, I first said, problem solving, but that's obvious, right? I mean, we need to have a problem solving ability. That's so very fundamental. But I think what's more important is opportunity selection. Which problem to solve? I think a person needs to be able to see that. I see that at a micro level within a particular project area, or at a macro level when you're trying to define a product or a project. Opportunity selection is very important. Now, we often say that we've got so many problems, right? We talk about all the problems that we face as a country. A flip side of that is a problem is an opportunity looking for a solution. So the good part is that we've got so many opportunities that we can pursue. So we need to build that mindset of opportunity selection. And I remember when I was doing my master's and I was interacting with some of my seniors who were at that point pursuing their PhDs. And I used to observe that they really would spend the first 1 or 2 years just doing research to identify which problem to solve, which problem is worth solving, because that requires them to do a lot of study in terms of the state of the art, what other people have done, what problems have already been solved, how have they been solved, is there a better way of solving those problems, are there new related problems that need to be solved. So we need to build that mindset amongst engineers in terms of opportunity selection. The first thing, so the second thing is we need to build systems thinking capability in them. They need to be able to look at things from a big picture perspective, right? What is the end application? What is the end objective? What is, again, tied to the opportunity or problem that we are trying to solve? Be able to look at it holistically as opposed to just very narrow in isolation. Here is one domain, here is one problem to be solved, and so on and so forth. The next one is team orientation, right? Nothing in the real world can be done by an individual. It always requires a team. And they need to be able to work together in a team. That requires multiple facets. That requires a sense of cooperation or cooperation, however you choose to look at it. Healthy competition, but with a lot of cooperation. That requires being able to we talk about the concept of self-directed teams, which means that they need to be able to look at what each other's strengths are and how to leverage those strengths. This requires strong communication and soft skills to be able to work effectively in a team. And this is so fundamental and foundational, and a lot of the engineers struggle with this because they are so used to working, competing. That part is taken for granted because they want to excel in their academics. But they're so used to just focusing on their work that they miss out on how to work together with others effectively. The next one is interdisciplinary expertise. Again, as I mentioned, a lot of the problems that need to be solved is all about convergence. It's, a lot of the technologies are coming together to solve these problems. When I reflect back on my personal academic experiences, and of course that's a long time ago. I graduated in 1986 from ITBHU, and then master's in 1988. The most valuable and interesting experience for me at that time was a project that we did to participate in a technology competition. Right, back in those days, it used to be called MODEX. Now I believe it's called TechNex at IIT Varanasi. And we were a group of engineers that came together from final year and third year students, came together from electronics, computers, and mechanical engineering, and built a 6 degrees of freedom robotic arm that could do pick and place programmable using an 8085 processor board back in those days. Now, pardon me if some of these things sound very archaic to you, but in 1986, this was truly unleashing imagination, right? I mean, robotics was not real and viable, and nobody used to talk about it. And this was an inspirational project, not just for us, but interestingly enough, for the faculty also. And I still remember that one of the faculty members got so interested that they literally, as a team member, worked with us on this project. And what that one project taught me, I think, was more valuable than everything else that I learned in the 4 years I spent in BHU. And this project, we literally worked for 4 or 5 months on this project. And it was a game changer in terms of all the various things that it taught us, all the failures we had, all the frustration we went through, all the workarounds we had to find to the problems that we were facing. Game changing, right? The last thing I want to talk about is they need to have, again, what education needs to prepare them, and the mindset that they need to have is all about bridging the knowing doing gap. And I think Professor Sahasrabudhe, as well as Mamta and others, spoke earlier that today all the knowledge is available at your fingertips, courtesy Google, right? So I find that these young kids know so much. They're so aware of various things, but their ability to apply it is limited, right? Limited. I wouldn't say zero, but limited. So they know if the knowledge base is 100, their ability to apply it is maybe 10 or less. And I think we need to build the mindset and provide opportunities to bridge this knowing doing gap. And again, that what that translates into is a lot more project focus through everything they do in their academic life. It's all learning by doing, and also a lot more emphasis on internships. And Professor Sahasrabudhe, you mentioned earlier, right? I mean, at Cadence, we take a lot of interns, and between the summer trainees and the 6-month interns, I can tell you that our experience tells us that the summer training is very limited. The time duration is very, very small for students to learn anything meaningful, especially if they're working in more advanced technology. A minimum of 6 months, maybe even longer, would be a good idea, right? And I reflect back on other industries and how engineering has evolved. I think we've missed a step. If you think about the chartered accountants, they go through an articleship multiple years, more than 1 year. If you look at medicine, right, doctors have to go through a 1-year residency in addition to all the hands-on work they do during their MBBS program. If I look back on engineering, right, back when I graduated, everybody was hired as a graduate trainee, and most companies would put the new hires through a 12 to 18 month effectively internship program, right? As a graduate trainee, you rotate through different departments, you learn different skills, you perform different tasks, a lot of learning by doing that used to happen there. And I think with the advent of the software wave somewhere in the 90s, all of that fell by the wayside, and the students go straight from 4 years of BTech straight into the job. That entire internship learning has been missed out. I think the 6-year internship is a welcome step. I would like to offer my suggestion as an extension that I think it'll be even better if that's a 1-year internship. And with all due respect, I think the summer training, it does help acclimate the students to a real world work scenario, but it is not enough for them to learn truly meaningful skills about the real world and the real technology. So I would offer those up as some thoughts as you embark on a week full of learning by doing through these FDP programs. Thank you very much for your patience in listening to my thoughts, and I'll be happy to answer any questions that you might have.
Thank you so very much, Jaswinder ji. It has been a wonderful, wonderful session, and I'm very, very sure that all our academic friends from academia, they have valuable take homes, and there are too many questions which are coming in. I would pick up a couple of questions, and one of the questions is that for sure semiconductor design will look different going forward, but how the pandemic has brought technological advancements in this specific domain?
There are a few different. So a couple of things, right? The good part is that we've seen an acceleration of adoption of digital technologies through the pandemic, right? We've seen a real acceleration of adoption of digital technologies, and most people say that we've jumped ahead 5 to 7 years. In the normal course of action, it would have taken 5 to 7 years for us to get to that point in time. But during the pandemic, we've really jumped forward that much. That's one part. The second part is, I think fundamentally the direction that we've been on, nothing has changed. The direction remains the same. I think a lot more new opportunities have come up. The first, for example, everything we look to becoming touchless, right? And I think that has caused an acceleration in some of the use cases for electronics in terms of more and more touch-free systems. In terms of the human-computer interaction, I think there will be an acceleration and adoption of natural language processing, voice control, gestures, and the like. So I would say that those are some areas where we recognize and which have been directly impacted by experiences through the pandemic. But for the most part, the only other change is that things have accelerated by about 5 to 7 years in terms of adoption of technology.
Okay, thank you. Another question is how to bridge the gap between academia and industry from your point of view? And one more, maybe it's linked. Do you feel that university industry linkages stimulate students' employability?
Yes, I think a couple of different things, right? So the faculty development program that all of you are having, which, as I understand, is going to be hands-on, is extremely useful and extremely valuable. What I would like to offer as a suggestion is, much like we've got the concept of internships for students, I think we also need to encourage a concept of sabbaticals for faculty members. If they can come and spend a few months, maybe in the summer or a semester, come and spend that in the industry. And we've done that in the past. We found that some of the academicians have come and spent time with us. And I think it is a wonderful experience on both sides. We benefit from some of the latest research that they've been doing and how we might potentially apply that research and what we are doing, and they benefit from getting an exposure to what's happening in the real world. So I think that there needs to be, I mean, everybody needs to be refreshed from time to time. And while the FDPs are extremely valuable, I think there's another step that can potentially be taken. I think an ongoing dialogue and exchange between industry and academia needs to be maintained. Joint collaborative research, I think there's tremendous opportunities there. Sponsored projects for MTech and PhDs, I think there's a real opportunity there. And as I mentioned, as far as the students are concerned, I would strongly advocate for 6 to 12 month long internships in the industry. So those are just some thoughts off the top of my head. I'm sure if we were to get into a more detailed discussion and brainstorming, many more wonderful ideas can surface.
Just one more question. What would be futuristic minor oblique major academic topics which should be included? But I think probably you would not really be aware of the syllabi for specific streams. So I'm not too sure whether you would be able to comment, but this is one of the what are the major oblique minor topics which would help in preparation for futuristic semiconductor designs?
Thank you. Again, you're right that I'm not familiar with the details of the curriculum, but clearly, you know, for example, you've picked machine learning as a focus area for the programs this week. I would say that let's take a step further down into the root of it and make sure that computational software, which is a foundation, that there is a level of emphasis on that, right? I mean, machine learning there'll be two facets to it. One is using machine learning and the other is research in creating the neural networks and other techniques that are the foundation of machine learning. So the application of machine learning, I think, is being democratized and will be fairly straightforward and easy. But creating the machine learning algorithms themselves, the neural networks and other techniques that enable it, I think the focus has to also be on that. That's where the maximum value will get created. And the foundation for that is computational software, which I think should be a big focus area. In terms of design, I think two things. If you do a real world project, now what happens in terms of semiconductor design is that the fundamentals of semiconductor design don't change that much. If you're looking at CMOS design will not change that much other than some shifts that happen with process nodes progression. And so when we went from, when we get into what's called deep submicron node, which is from the 35 micron and below, techniques, some of the physical effects started to come into play and the design techniques started to evolve. So advanced node design that we are currently at 7 nanometer, I don't think too much more will change beyond that. So if we can prepare the students for advanced node design conceptually, including things like the effects of physics on design and design reliability and statistical methods that come into play in design, if we can prepare them for that paradigm of design, I think they'll be well served for the next 5 odd years. And by then things will change and all of us need to relearn. I don't think anyone can predict what will happen at that point in time.
I'm just
But
taking
some of
one
the
last. Sorry.
Mamta, just one point. Some of the other concepts that I mentioned earlier, I think are important, and I would elevate myself from just semiconductor design to electronic design. It's the systems thinking, the interdisciplinary approach. I think those things become very important in electronic design. And I would really focus on electronic design and not just semiconductor design.
Just one last question, which I am taking because we have almost coming to the end of the session. That why industry is quite forthcoming in developed countries, whereas such is not the case in India. So I think this is one of the questions many participants have asked.
Yeah, I think there is some gap in our level of understanding on this topic. First of all, I think industry. I can speak on behalf of Cadence, and I can speak on behalf of the India Electronics and Semiconductor Association, and I can speak on behalf of many industry colleagues that I have. I think industry is more than willing to come forward. Every single company I know is actively engaging with more than one um, academic institute in a fairly deep way on joint research, sponsored research, internships, some of the other things that I mentioned earlier. So I don't think that there is a lack of willingness. Sometimes I do wonder. I think we have many more engineering colleges in India than the US, for example, or all of the Western countries put together. And maybe this is just a mismatch in terms of the number of industries and the number of academic institutes, and as a result, not full coverage in terms of all the academic institutes being able to get the attention from industry, because industry obviously is somewhat bandwidth limited in terms of how many academic institutes it can partner with. So that's just a point of view. I could be right, I could be wrong. I can't be sure about that, but that could potentially be one of the reasons. But I can assure you that industry, almost every single company that I'm aware of, is more than willing to and is actively working with multiple engineering colleges.
Thank you so much. Just one question from me. Now, this is from my side. Since I'm steering faculty development programs through ATAL in AICTE, what is one single most important thing you would like me that we should at AICTE be implementing to make our faculty development programs much more hands-on and much more so that they are able to take whatever they are understanding in faculty development programs effectively transact in the class? So this is my question for my understanding.
Yeah. So I would go back to emphasize the last point I made, which is it is all about bridging the knowing doing gap. I think the faculty are very well informed. I think the access to knowledge has been truly democratized courtesy Google, and all the research papers are available, and you really don't have to step away from your computer to gain all the knowledge. I think it's really understanding the real world context and the application of the knowledge that is a challenge for every one of us. And I don't want to point out just it's the faculty, it's all of us staying abreast of the latest trends and application of knowledge. And so if there is one idea I could offer, I would say um, faculty sabbaticals to go spend time with industry, whether it is during the summer, whether it is a semester off every 3 to 5 years. And I have had faculty members taken sabbatical and come spend time at our company. And I honestly can say that there is a tremendous amount of mutual benefit that both sides gain through that experience.
My heartfelt gratitude. Thank you so very much for this wonderful session. And I'm sure each one of us, our coordinators here, would agree with me that we couldn't have asked for any better session. Thank you so very much. You may
Thank
be
you.
formal vote of thanks if you can just conclude in a minute or so. Thank you so much.
Thanks, sir, for enlightening the session with your views on evolving trends, disruptive technologies, academia-industry linkage, and translating research into impactful applications. Now, adding on a very hearty vote of thanks to all the speakers for gracing your important work and sharing with us your findings and opinions of today. Thanks to the AICTE Academy, ATAL Academy, for such an initiative that has been conducting various FTPs for imparting, upgrading faculty knowledge in thirst and emerging areas. I would also like to extend thanks to all the 63 coordinators who helped make this program successful and the technical staff members who made sure the event occurred without any technical difficulties. अब मैं कुछ लोगों का धन्यवाद प्रकट करना चाहूंगी जिनकी सहायता के बिना इस कार्यक्रम को ऊंचाइयों तक पहुंचाना संभव नहीं था। ई गवर्नेंस सेल की टीम ने पोर्टल डेवलप किया एवं इसके द्वारा एफटीपी का सफल संचालन किया। इसके लिए हम उनके आभारी हैं। मीडिया सेल एवं मीडिया एजेंसी ने इस कार्यक्रम को देश के कोने-कोने तक से जोड़ने एवं सफल बनाने के लिए हमें सदैव सहयोग प्रदान किया। इसके लिए हम आपका धन्यवाद ज्ञापित करते हैं। अखिल भारतीय तकनीकी शिक्षा परिषद के समस्त ब्यूरोज तथा सेल और साथ ही परोक्ष या अपरोक्ष रूप में हमारे कार्यक्रम में सहयोगियों की सहभागिता के बिना भी इस कार्यक्रम की सफलता संभव नहीं थी। अतः उन सभी को हम हृदय से आभार व्यक्त करते हैं। अखिल भारतीय तकनीकी शिक्षा परिषद के समस्त क्षेत्रीय अधिकारी, एफटीपी आयोजित करने वाले समस्त इंस्टीट्यूट एवं यूनिवर्सिटी के प्रबंधक, उनके फैकल्टी मेंबर्स तथा प्रशिक्षण प्राप्त करने वाले तकनीकी शिक्षण गणों का भी अखिल भारतीय शिक्षा तकनीकी शिक्षा परिषद परिवार उनके सतत सहयोग के लिए आभार व्यक्त करता है।
धन्यवाद मिताली सचदेवा जी, धन्यवाद। अब हम इस कार्यक्रम का समापन करेंगे। सभी लोगों को हमारा सादर धन्यवाद। थैंक यू सो मच। थैंक यू। हैव अ गुड डे। जय हिंद।
Thank you to all.